Okay, in 3.2 what we're going to be doing is working with some properties of addition, subtraction, and equality. So the big difference now is that we're talking about equality of things. So first, some definitions. An equation is a mathematical statement showing the equality of two expressions. It consists of two expressions, one on each side of the equal sign. So we're all familiar with the equal sign, and an equation is anything where we have an expression on the left hand side and an expression on the right hand side. So it's important to be able to distinguish between an equation and an expression, and that's actually very easy because an equation will always have an equal sign, always. So let's determine which of these are equations. This is an equation, has an equal sign. This is an equation, has an equal sign. This is not an equation, it's an expression. This is an equation, and this is not an equation because it does not have an equal sign. That's an expression. So that's just double checking, make sure we're always looking for an equal sign whenever we're talking about equations. So now, let's say we're given this equation. We're told that this is a true statement. What we're trying to do here is figure out what x would have to be in order to make this true. So what number plus 6 would give us 8? Well, we can just think about that and realize that the answer must be 2. If we replace that x with 2, then of course this is a true statement. So that's what we're trying to do when we're looking at these equations that involve variables like this, right? We're trying to find a value for that x that will make the equation true, and that's what the next little note says. A solution to an equation is a value that when substituted in for the variable causes the original equation to hold true. So in the example above, the solution, right, 2 is our solution, all right? So we'd write that as in what we call set form. Oops. Set notation. We just put a brace and then we put the number 2, and that is our solution set. To determine if the value is a solution to an equation, simply substitute the known value into the equation and verify. So let me show you how this is going to work. So let's say that we're given an equation. Here it is. That's an equation. We can all see the equal sign there. And it's asking us, is p equals -2 a solution, yes or no? So what we're going to do is we're going to check. We're going to write down the original equation, 6, but instead of putting p here, we're going to replace p with -2. So I'm going to go, I'll put it in red here. So we're going to be multiplying by, whoa. Okay, we're going to be multiplying by -2. So that's 6p, and then plus 7. Is that equal to 5? This is a question. Is this true? So 6, we do multiplication first. So 6 times -2, it's -12 plus 7. Is that equal to 5? Well, -12 plus 7, that's actually -5 on the left-hand side, and that is not equal to 5. So the answer to this is no, that is not a solution. We need that to be equal at the end. So how about this one? Is 4 a solution to this equation? So I'm going to write the equation down. 5. I'm going to replace x with 4, so times 4. And then continue writing the equation. -9 equals x. Now x we said was 4. And then plus 8. So let's see if this is true. This is a question. Is that true or not? So we multiply here first. That's going to give us 20. Take away 9. Does that equal 12? Just 8 plus 4. And 20 take away 9, that's 11. And that is not equal to 12. So that's not a solution either. Now, there are solutions to things. Don't worry. We're not going to get paranoid here that we never get solutions. All right? Because we do. It's just those two examples we did not have it happen. So, okay, so now we'll get into the main idea here, how we solve linear equations. So to solve an equation means to find the value of the variable that makes the equation true. In other words, to solve the equation means to find the solution. So when we're solving equations, we want to be able to work with the equation, and these two important properties are what we're going to use to solve equations. And what these properties say, the first one says, if you have an equation, all right, let's say you have an equation, then you can always add something to both sides of the equation. As long as you add it to both sides, the equation remains true. The second property says if you start with an equation, you are free to subtract a number from both sides of the equation and it will still remain true. So we don't change anything with the equation if we add or subtract things to both sides. So when we're solving linear equations, what we're going to be doing is we're going to be looking at the equation, first of all making sure it's an equation, and then we're going to try, and this will be the technique we always use for linear equations, we're going to try and isolate the variable x. So we're going to try and get that x by itself. Now the way we're going to do this is we're going to realize that we have x minus 7 equals 2, but what I want to do is since I want the x by itself, and I'm going to do something to get rid of this negative 7, and what I can do to get rid of it is I can add 7 here to that side to the left side of the equation. And then what I'll do, let me do that add 7 in a different color. So I'm going to add 7 to that side. Now the other side is 2 equals 2, and what I'm going to do over there is I'm going to add 7 at the same time. So that was using the property from above. We took the left side of the equation, which was this, and we added 7 to it. We took the right side of the equation, which was 2, and we added 7. And that had the effect of canceling out this 7 and negative 7 go away, which leaves me with just the x over here. And then equals, now we still have to combine these two together, and you get 9. So our solution should be 9. Now let's just check it. Our original equation was this. If we plug 9 in for x, we should get 9 minus 7 equals 9. Sorry, I put 9 here. I meant to put 2. So is this true? Yes, it is. Okay, let's try these. These are group works, but I'll go ahead and work through them. So we're trying to isolate x. So what I need to do is get rid of that minus 9. So I will add 9 to both sides. So I have x minus 9, going to add 9 to the left side. On the right side I had a 1, but now I'm going to add 9 to that side. These 9s cancel, which just leave me with x on the left side, and on the right side we have 1 plus 9, which is 10. So our solution is 10. Okay, on this one I'm trying to get the variable by itself. I have plus d here, so it'd be nice if I could get rid of that minus 35. So what I'll do is I will add 35 to both sides. So watch how I do this. Negative 50. I'm going to add 35 here on the left side, and then I had the negative 35. I'm going to add 35, and then I still have there the plus d. And so the whole effect here is that those go away to 0, which leaves me with just d over here, and over on this side, negative 50 plus 35 is negative 15. There we go. Okay, so now let's try using the subtraction property. So if we have this one, we're trying to isolate the x. We have plus 16 next to it. So in order to get rid of a plus 16, I'm going to have to minus a 16 or subtract a 16. Come on. Subtract 16 on the left side. Whatever I do to the left side, I must also do to the right side. Okay, these 16s go away, which leaves me just with the x. And then over here I have to do negative 5, take away 16, that's going to be negative 21. So that is my solution. Alright, on these, you can pause it if you want, but I'm going to keep rolling away here. We're trying to solve for w. We have a plus 17 next to the w, so what I'm going to need to do is subtract 17 on both sides. So here's 9 on the left side, subtract 17 there. On the right hand side I had a w plus 17, but I have to subtract 17 there. So these 17s will cancel. The left hand side I get negative 8 equals w. And then here, I'll go a little faster here. I'm going to have to subtract 3 on both sides to get that m by itself. So negative 10, I have to subtract 3 equals m plus 3 minus 3. These 3's cancel. We get negative 13 equals m. All right, that's it. Now, let's put a little more in here. Sometimes we actually have to do a little bit of simplification before we can do the technique we just used. So, for example, this problem here, we still want to solve this for x. The problem is we have 2 terms that have x in them, right? So what we'll do is we'll combine any like terms together to start the problem. So before we do anything like adding or subtracting on both sides, we're going to combine like terms. So these are like terms, so we can put them together. So that would be 11. Negative 7x plus 8x would give us just plus 1x. And on the right hand side, these are like terms also. I can put those together, that's minus 6. And now we just play the same game we just played. I need to get x by itself. So what I'm going to do is take away 11 on both sides. So I'm going to do 11, and I'm going to take away 11 plus x. And then on the other side, I have minus 6, but I need to take away 11. So I'm not doing it in a different color now, but here's the part that I'm using the property of. I'm taking 11 away from both sides. And the reason I did that is so that these will go away and leave me just with x. And then this one will be minus 17. All right, that's it for that. Here's a group work, but I'll work through it now. Pause if you wish. Okay, for here I have k, but I've got k inside of a parenthesis. So what I'm going to do first, I'm going to use my distributive property and multiply the 4 through here first. I'm also going to combine these 2 like terms together to give me a 3. When I distribute through, I get 4k, get plus 8, and then I still had minus 3k. So that was my distribution through here, gave me the 4k plus 8. Now I also noticed that I have like terms here, so I can combine those 2 together. So I will have 3, let's see, 4k take away 3k, that's just 1k right there, plus 8. And now I'm finally ready to do something to both sides, and need to get rid of that positive 8, so I'm going to subtract 8 on both sides. Eights cancel here, and on the left side I get negative 5 is k. There you go. So that's it for that section. That's pretty quick, but you definitely need to practice. Make sure you get good at doing this without making any mistakes.